The absolute value has a unique effect on the graphs of very familiar functions, and it's worth taking a look at how that effect changes the domain and range of some familiar graphs. So if you look here, I have a bunch of different graphs typed over here on the left for us to look at. And you'll notice that after each one of them is the absolute value version of each one. So we have a line and then the absolute value version. Then we have a quadratic, a parabola, and then the absolute value version. And what I wanted to look at in this video is what happens when you take the absolute value of an entire function. So it's worth remembering that anytime you take the absolute value of anything, it's an examination of distance from zero. So in the case of the XY coordinate graph, it's an examination of the distance from the x-axis, because all of the points on the x-axis are where y is equal to 0. When you say take the absolute value of this, you are suggesting then that you are looking at how far away that point should have been from the x-axis. So if we start by looking at our line, we get this very familiar shape. We have this section here that it crosses the y-axis at 0, 3. That's our y-intercept. We have our x-intercept over here. But we have our very straightforward line. When I pop the absolute value around it, I am then saying I would like to graph this line, but instead I want to graph it by looking at the distance from 0 of each of the coordinates. So if I come down here, for example, to this coordinate right here, you'll see at -2, -5, that I am -5 below the x-axis. What the absolute value is going to do is it's going to look at that point and say, you are not -5, you are 5 away from the x-axis. And it's going to do that for all of the points. From there to here, this one's not going to go anywhere because it's 0 away from the x-axis. To there, that one's 3 away. And it's going to do it for all of the points along the curve. So when I graph this, watch what happens. Now it's a little difficult to see because the green went right on top of the blue, but I now have this green section coming down here, and then the remainder of the graph is going up there. I'm going to turn this off so you can see it. There's the remainder of it. So I have this blue line that was my original line, and then the green is going over it for half of it, and then on the other half of it is now pointing upwards, and that's thanks to the absolute value. This point down here was at -2, -5. And as you might guess, that point is now at -2, 5, because it's a measurement of distance. Now, what effect does that have on the domain and range? Well, realistically, it shouldn't have any effect on the domain. You are still putting the same numbers into that absolute value that we were putting previously. You still need that same math to happen. But realistically, what it's going to change is the range, because it's going to force all of these outputs that were below 0, all of these outputs all the way in perpetuity, it's going to force them to be now above the x-axis. And it's going to force them to go positive. So while this first graph here had a range of all real numbers, this one's range is only going to be y is greater than or equal to 0, because it's forcing all of those points that were below to come above the x-axis, thanks to the distance measurement. Here's a parabola. We'll zoom out a little bit so you can see the parabola a little bit better. Same logic is going to hold here. Domain, all real numbers. Range, looks like we have a bottoming out point at 1, -9. So I would say we had a range here of y is greater than or equal to -9. We definitely have a point there down at the bottom. And if I go to bringing in the absolute value version of that function, I get that it now goes over top on the two sides. And I again get this mirror image where the bottom part of the parabola that was below the x-axis is now flipped above. And that's exactly what it is. It's reflecting that absolute value is having the effect of flipping that part of the graph that was below to above the x-axis. And now it's going that way. These points that were way down here, 1, -9, 1, 9, we're now looking at distance. 0, 7 was previously 0, -7. These points looking at distance, where they would have fallen if we graphed them, These points we're looking at the actual XY relationship. So because I did that change, because I put that absolute value around the outside, now everybody is greater than or equal to 0. As difficult as this might be to look at or read, the same exact thing happens if you have an absolute value function and you put an absolute value around the entire thing. We still get that overlap on the outsides, and we get that part that's below the y-axis to now be above the y-axis. Our previous bottoming out point was -4. Now, on the blue one, we don't go any lower than 0 because of that distance measurement and that concept behind it. Here's an exponential that goes all the way down to -7. If the same logic would hold, we would expect anything that was below the x-axis, which is this big swath of graphing right here, we would expect all of that to go above the x-axis, and that's exactly what happens. We have overlap between the parts that are above, and we get this mirrored reflection of the lower part to above the axis. Our range previously went all the way down to -7. This is one of those graphs that has that line that it doesn't cross at the bottom. But now we have this line over here that we don't cross. That doesn't really affect the range because that's not the bottoming out point of the graph. The bottoming out point of the purple graph would still be over here. But we still get that mirrored effect. Maybe the most interesting one to look at would be the square root function, which we've worked with a little bit in this section. Here we get this graph that's going off to the right. We've moved 3 units to the left and 3 down. I have my starting point at -3, -3. I've got this intercept at -1.268, and then I've got this x-intercept over here of 6.0. When I place this inside the absolute value, I again should anticipate the same thing happening. And fortunately for us, it does. And I know it's a little hard to see the blue part over on the right, so we'll get rid of the red one real quick so you can see it. We get the exact same section over here, that overlapped part, and anything that was below the axis comes above. What I thought was most interesting about this was that the inclusion of the absolute value didn't expand the domain at all. We were still limited by this square root function. We couldn't go beyond that in terms of domain. That was where we were limited to. We were limited to following the rules of the square root. Just because I put an absolute value around the whole thing doesn't change the fact that I was limited in my original domain. I still, if I tried to use, say, -10, I still wouldn't be able to get past that square root in order to get out to the absolute value. So adding an absolute value to the outside of the whole function doesn't change the domain. It just flips everybody up and gives us all of these ranges of y is greater than or equal to 0.